from our perspective, when you think of the acquisition of 5C and what we've done, we recognize that the biggest constraint in being able to grow this infrastructure and scale the AI workloads in 2025 and 2026 and beyond is really data center capacity, right? And when I say data center capacity, I'm not talking about smaller capacity. I think you could still find some capacity here and there, but to really deliver, like you said, this larger size clusters at scale, there's a gap. There's a gap in the industry in terms of capacity, and I think our acquisition of 5C, combined with our partnership with Together, is what really helps us address that market problem in terms of getting capacity up and running fast.
Right.
And we're talking about hundreds of megawatts within 25 and early 26, when really what's out there is really nothing available until late 26, early 27. We all know these users need to start training as soon as possible with the latest chips. And having that capacity available and working together with you guys is really solving one of the key issues that I feel is plaguing the market right now.
Yeah, no, absolutely. It is, I would say at this point, last year when we started working together, it was really constrained on chips.
Yes.
And it felt like, it was quite unpredictable when you would get deliveries from NVIDIA and OEMs. But I think that seems to have been, and that supply chain has been optimized more. And there's still a constraint, like as we are discussing with some of the things we're working on, but it seems less of the sort of long pole now. But it's very clear that there's no data centers, right? That there's very, very limited data center space, and where do you put these chips? So that's how do you think this sort of progresses in the coming years?
So I think it's going to be a question of who can adapt to the environment. I think that if you look at the data center industry, these are players that have been around for a long time that built based on a data center company would build based on whatever the reference design was at the time.
Right.
The thing is, when a technology evolves this quickly, you need to kind of get ahead of it. You can't just wait till the next Blackwell chip comes out and wait, now I have to increase the density from 140 to 200 kilowatts a rack, right? So I think the way you address this is you get ahead on the roadmap. You don't just wait for someone to publish a next best kind of data center design. And that's what we've really been focused on, is really being able to find the right land and shells that have power available soon. When I say soon, is within the next 1 or 2 quarters. And then really design it for the future. Don't just design it for today. And make sure your design is flexible.
Right.
Because whatever you're delivering this year will fundamentally change next year, right? And that's what we're seeing today with Blackwell and Rubin, right? And we saw that with Hopper and Blackwell as well. So that's what we have. This is where our expertise on the HPC, on the computing side, really benefits the data center business, because we really integrate that expertise into our designs. We're not just waiting for some OEM or a semiconductor to tell us this is how you should build your data center.
Right.
We already know how to build it, right? We already know what those roadmaps look like. We have labs where we're testing all this infrastructure live to see what will we need in terms of cooling. How should we cool it, right? So, and this is also where we get into efficiency and sustainability, because sustainability, there's a question of trying to help the planet and reduce carbon footprint. There's also a question of getting more chips in the same data center, in the same power envelope, right? So there's a play on, saving the environment, but also being able to scale faster, given you're able to fit more chips in the same power envelope. So for us, we see that as being essential to the scaling process. It's not just a question of building that out the capacity for the future, but also building it in such a way that it's efficient and that you're really reducing your power usage effectiveness, where for every watt of power that's required by these GPUs, you're using the least amount of power to cool them and operate them.
Right.
And that's really what we want to focus on.
And that's the PUE
Correct.
Of the data center. You really want to sort of improve that number
Exactly.
over time for just given the power usage is going up.
Reduce the carbon footprint and increase the amount of chips we can fit within the same data center power envelope.
Yeah, that's fantastic.